All right, guys, this is going to be our video for 8.1 through 8.3. Now, what we're going to do here is we're going to learn about quadratics graphically, then we're going to go back and learn how to do it algebraically. So up till now, we have talked about two forms of equations, really. We've talked linear and we've talked exponential. Now, linear is anything with x to the first power. So we knew it would be like y equals, let's say, x plus 2 or anything. And just like linear, remember how we knew we could have it in different forms, y equals mx plus b, and then you could also have y minus y1 equals m outside of x minus x1. So, and we also had, ax plus by equals c. So we had slope-intercept form, point-slope form, and standard form. So when we dealt with lines, they all had different reasons. This could be graphed really easily. This could be used if all we knew was a point and a slope. This was really good for finding the x and y intercepts. So now we're going to think of the same thing, but we're going to look at x squared. So we already did exponentials where x is in the exponent. We looked at x to the first power, linear. Exponentials, x in the exponent. Now we are going to look at x squareds. X squareds can come in multiple forms. So I'm just going to give you the three main ways. So this is the standard form of an x squared. So y equals a x squared plus bx plus c, where a, b, and c are just numbers. Okay? This is called standard. Next, we have y equals a outside of x minus h squared plus k. This is called vertex form. And our last one is y equals a outside of x. And then really it could be anything here, but it's two parentheses. And it'd be x minus, you can put really any letters here. You don't want to use h and k. I'll just use m and x minus n. Okay? And this one is called intercept form. Some people will call it factored form. Some people will call it, sorry about that. Some people will call it factored form. Some people will call it linear factored form. Now, all of these will give you a graph that's called a parabola. And we're going to get into that in a second. But just so we're clear, just like with lines, there are multiple ways to represent what we're going to be talking about now, which is quadratics. Okay? So x to the first power, linear. Quadratics are when you have x to the second power and other things. So just to be clear, we're shifting gears now and we're going to look at things called quadratics, which is the form of the equation. And then they make a graph that is called a parabola. So it's a little bit weird because when we were talking about lines and linear, well, a linear graph makes a line. A quadratic makes a parabola. Okay? And just for lack of anything better than that, a parabola is a U shape. It can be facing up or facing down, and that's really all we're going to get into during this year. And right now I'm letting Desmos come up, because like I said, we're going to do everything graphically. So right now I just want you to see, I'm going to have one line showing up in three forms, but it's going to be the same graph. When I say line, just so we're clear, a line doesn't always mean a straight line. When we're talking graphically, I might use the word line, and it's talking about a parabola, okay? So let me get the light so you can see this a little bit better, and it'll start to brighten up for you. And apparently the filter on this thing's a little dirty, sorry about that. But you see how we have three different forms of this quadratic. We have, what I told you, was vertex form. And then we had factored form. and then we had standard form. And I'll shut these off just so you can see all the different things. See how it's the same one every time? Blue, green, or purple. So anyone can work for us. I just want to be clear, because what you're going to be doing in the beginning is just putting things on the graph and then finding the important parts of a quadratic. That's what we're going to be working on now. So I just want you to be familiar. If you see any three of these forms, you know when you graph it, you're going to have a parabola. Or if you do a graph and it looks like a parabola, you know you're talking about a quadratic. Okay. Since I'm not going to be really testing you guys at this moment on the different forms, this is what we're going to be talking about. The parts of a parabola. And let me zoom this out a little bit. I just want this to look a little bit nicer for you. Okay. So there's some parts we should already be very familiar with. X-intercepts and Y-intercepts. The X-intercepts are where you cross the X-axis. Remember, intercept sounds like intersect. So for the X-intercepts, I'll do those in black, and those are these two, where you cross the X-axis. So if I'm asking you to label the X-intercepts, I would say -2, 0, and 6, 0. So we're just looking at a graph of a parabola and naming things. The Y-intercepts. The Y-intercept is wherever you cross the Y-axis. Here we go. So the Y-intercept is at 0, -12. And you notice Desmos will give you all these points. Now, we're going to switch over and we're going to talk about something called a vertex. A vertex is just an inflection point or a point where something turns. No matter whatever we're talking about, when I say vertex, it's a point where something turns. So you can see this thing's coming from left to right. It's coming down, 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 and it turns right here and then goes back up. Luckily for us, they will give us the vertex. Okay? So right now we can see the vertex is at 2, -16. And I hope that that green is coming up enough. It appears to be. So we only have 2 more things to really talk about. This vertex gives us a lot of information. And I hope one of it is very obvious. This vertex is either going to be a maximum or a minimum. Because remember, I told you parabolas can be like a smiley face pointing up forever, or they can be flipped and be going down forever. So first you'll find the vertex, and then you're going to have to tell me, is the vertex a maximum or a minimum? And it should be really easy to see. If the vertex is at the bottom of the parabola, it's the minimum. If it's at the top, it is a maximum. Okay? So we know the vertex is going to be a minimum. But if they ask what is the minimum, they're not asking for the whole point. If they ask for the vertex, you give the point. If they ask for the minimum, you give me the Y value. So make sure that's clear. Min and max will be the Y value of the vertex. So if I was going to answer this, they say, what's the minimum? I would just say the minimum equals -16. When they're talking about minimum, they're saying, what is the smallest range, or what is the smallest Y value, or what is the smallest output you can get from this function, okay? Now, there's only one last thing to talk about. We're going to look for a line of symmetry. Now, symmetry, we should know, is where you can cut something in half. So, like people, you can cut pretty much right down the middle here. and have a line of symmetry. Hopefully you notice when you look at this, the vertex is always our best indicator of where the line of symmetry is. So I could cut this parabola right down the middle, right there. Okay? So we know we're going to have our line of symmetry that passes through the vertex. Now, when you look at the line of symmetry, we have to remember back to our lines. Hopefully you can remember the concept. I'm going to write this up here because I don't want to go along with this stuff. Hopefully we still remember hoi, vox. Because when I look at this line of symmetry, like every other line of symmetry for a parabola you'll ever have, it's going to be a vertical line. Okay? If I have a vertical line, am I thinking hoi or vox? You should be thinking vox. Hoi was a horizontal line, zero slope, and the equation is y equals. But that's not what we're doing right now. We're doing a vertical line. So we're thinking vox. A vertical line has an undefined slope, and the equation is x equals. So if I'm looking for my line of symmetry, it's going to be x equals the x value of the vertex. So in other words, the line of symmetry equation is x equals 2. Okay? So this is just analyzing a parabola. We have a parabola that opens up. Now let's talk about all of the important parts of the parabola again. The x-intercepts are where the parabola crosses the x-axis. Now you could have 1, you could have 2, or you can have 3. Just imagine it's a U-shape, right? So if the U-shape is below, you'll cross twice. If it was right on the x-axis, it'd cross once. If I drew a parabola above it, it wouldn't hit at all. Okay? So it is possible to have 1, to have 2, or to have 0 x-intercepts. Okay? You're just going to have to look on the graph and find them. Easy enough, I hope. Ask me in class if you have questions. But x-intercepts, where you cross the x-axis, give me the points. If they just ask for the number, sometimes it's fine. The computer will guide you. Y-intercepts, where you cross the y-axis. Okay? So the y-intercept is where you cross the y-axis, and this one is 0, -12. Next, we talked about the vertex. The vertex is the point where you either go to the very top of the parabola or go to the very bottom of the parabola. It's the point where the parabola turns. So we found our vertex was at 2, -16. And then we realized, okay, well, this is at the bottom of the parabola, so the y value of the vertex gives me my minimum, which we talked about here. And then this gives me my equation for the line of symmetry. So this would be for the line of symmetry. Okay? And I went over, it should be a vertical line, so it has to be x equals. It's going to be x equals the x value of the vertex. This, honestly, is about enough to get through the entire assignment that I gave you for 8.1, 8.2, 8.3. We are going to come back, and this assignment is going to get harder when we learn how to do this algebraically. But for right now, we're just going to immerse ourselves into a parabola, into the world of quadratics. So you're going to have a choice board assignment that talks about important parts, and then you're going to have a homework assignment. And for the remainder of this video section, I'm going to go through a couple homework problems that should be able to guide you through your homework. All right? Thank you very much.